Hello friends, I am Parthapatim Chakravarti from Department of Geology, University of Delhi. Now today in this module, we will be discussing about the carbonate platform. Now once you go through this module, you will come to know what is called carbonate platform, what are the different varieties of carbonate platform, what are the processes that operate in the carbonate platform. You will be also able to understand that how the different processes and their mutual association that vary with variation in the carbonate platform. What are the role of tectonics and sea level that basically control the carbonate platform in terms of its growth and evolution. You will also be able to understand that what are the products of different carbonate platform geometry and how we identify those products in the rock record, so that we can interpret the carbonate platform which was existing in the geological past. So friends, as we have already discussed that we will now go into the detail of carbonate platform. Now where we get the best of carbonate production? We get best of carbonate production in shallow oceanic environment which is illuminated. That means supply of light and the shallow, that is the oxygen availability, all are equally important for carbonate production. Overall, if we see the carbonates, they are of two major types, that is, one is the precipitate, another is the skeletal fragments. If we see the phanerozoic carbonates, they are mostly biological in origin and composed of the skeletal fragments of organisms. But if we go to the Precambrian carbonates, particularly Proterozoic carbonates, the microbiota that replaces the skeletal components. And if we go to the further old, that is the Archean carbonates, they are mostly fragmentary and clastic, and that's their ancestral, that where from they are coming, that is often very dubious and conjectural. So once we know that the carbonates, they are basically product of all these precipitates and the skeletal components, where we expect to form the best of the carbonate platforms. We expect the best of the carbonate platforms to be developed in the passive margin settings. Besides that, we can also get some carbonate platform in the intercatonic basins, or you can get it in the back arc. But normally those settings which are tectonically very agile, suppose a foreland setting or a rift setting, there it is difficult to have a thick carbonate succession or a carbonate platform because of the high terrigenous influx. So the best possible area where we get the carbonate platforms to be formed, where carbonate productivity is high and terrigenous influx that is very low. So once this kind of condition is developed, then we get the carbonate platform to be developed. Now, what we expect that the carbon in the on the surface of the earth, where best of the carbonate platforms we expect. We expect the best of the carbonate platforms to be developed in between 30° north to 30° south latitude, where it is the most favorable condition for the carbonate production and the carbonate development. Now coming on to the different geometry of the carbonate platform, the carbonate platforms, they have the different geometry, and according to the geometry, the carbonate platforms, they are classified into different types. As we have already described that how I describe a carbonate platform, it is a thick succession of shallow water carbonate, that is what we call a carbonate platform. Now this carbonate platform, it can assume different geometry, and also one geometry of carbonate platform that can evolve to the another geometry of the carbonate platform. Now as carbonate platforms, they evolve from one geometry to another, so it's very important to understand that what geometry at different time plane a carbonate platform is assuming and how they are changing from one geometry to another, because that will control the facies disposition of the different carbonate platforms, and that in turn will cause the changes in the porosity and permeability in the sediments that is formed in a carbonate platform. And as I have already talked that many of the carbonate platforms, they are the large scale hydrocarbon reserves of the world. So the porosity permeability development, the facies distribution of the carbonate platforms and their geometry, their controls on the facies distribution, that is of immense importance for all the carbonate sedimentologists. Okay friends, now let us discuss the different kinds of carbonate platform in terms of geometry. In terms of geometry, the carbonate platforms, they are classified into certain types. These types are so, as I have drawn, I am just explaining to you the different kind of carbonate platforms. These two which I have drawn here, these we call this type of platform as ramp. You can see there are two different geometries that I am drawing in terms of ramp. One, this we call the homoclinal geometry, homoclinal ramp, and this we call the distally steepened ramp, distally steepened. Then this, what we are seeing in a homoclinal ramp, from the proximal to distal, it is very low gradient, and this gradient normally is less than 1 degree, and what we get in this kind of ramp is that from proximal to distal, the energy level that will be successively decreasing. In the proximal part, what we get the wacke and pack stone, and as you go away from in it, you will get the more and more mud content that is increasing into the carbonate. Mostly in the shallow water part of this kind of ramp, it is wave dominated, and the relative energy of the ramp that successively decreasing as you go to the deeper part of it. Initially, this kind of ramp that was classified into three different components. These ramps were classified as three different components, that is the back ramp, the main ramp, the shallow ramp, and the deep ocean. But Burkett and Wright, they further classified the ramp into the four different components based on two surfaces. One is the fair weather wave base, what we refer to as FWWB, and storm wave base, we refer to as SWB. Based on these two surfaces, the ramps are further classified into the four different components. We get a inner ramp which is above the fair weather wave base. Which is above the fair weather wave base. Here, if your fair weather wave base intersects the ramp profile here, then above it, this portion that you call the inner ramp. And you have the storm wave base that comes here. So the zone between fair weather and the storm wave base, that is what is called the mid ramp sector. And then the portion which is away from the storm wave base, which is further down, that is what is called the deep ramp, and finally we get the basin. Now normally this kind of ramp, it is a homoclinal ramp which is a very low gradient system. It is almost parallel to that of a siliciclastic passive margin system. But when there is some kind of slope development at the distal part of this ramp, then we call it a distally steepened ramp. Now why this slope will generate at the distal part of this ramp? Sometimes it is because of the tectonic. And the tectonics cause the distal portion of high slope. So when no mass flow will be available in this kind of ramp because of the very low gradient of the ramp, then here because of the slope generation, we get the generation of the mass flows, that is the turbidites or the density flows associated with the distally steepened ramp. Now coming on to this so from ramp we are now going to this kind of a setting, what we call the rimmed shelf. What happens in this rimmed shelf? In rimmed shelf, what we get, that we generate a reef at the shelf edge. Now shelf edge is a very favorable zone for carbonate production, because that is the zone which is in the profile one of the shallow zone, and all kind of oceanic wave that basically breaks along that zone, that creates a wave agitation and the shallow depth, which totally help in the carbonate production. So, the growth of the reef at the shell page, that basically creates a low energy zone at the back of it in the form of a lake or a lagoon. And that is a typical character of a rimmed shelf, because there is a rim at the shell page which is causing the wave to be baffled, that the open ocean wave that is getting baffled, and that ocean wave cannot enter into the energy shadow zone at the back of the reef. That is a typical character of the rimmed shelf. Now, how we basically see the facies distribution in this kind of a setting? We get this portion of the reef that is called the forereef part, and this forereef part is of high slope, and it is associated with the mass flows, that is the clastics of the proximal and the distal clastics. So, we can have the high slope, the clastics that is supplied because of the continuous wave pounding onto the steep slope of the reef, and the sediment that is being generated because of the steep slope, which get deposited along the slope from the proximal to the distal part. Then you get the main reef part, that is the reef core and the reef crest part, that is this portion we call the reef core or reef crest part, and at the back, that is what we call the leeward slope of the reef. This is called the seaward slope, or windward slope, and this side of the reef we call the leeward slope. So, if I have in the windward slope we get the steep slope and the talus that is supplied from the reef. On the leeward slope we get the low energy environment, that is what is at the back of the reef we get this kind of a environment. It is a typical of the rimmed shelf that we get. Now, these reefs, that they can be of different type. We divide the reefs depending on its position with respect to the geomorphic position with respect to the land. The reefs are also classified into certain types, such as fringing reef. Now, what is fringing reef? Which is almost attached to the land, that is what we call the fringing reef. Then we get the circular reef. The circular reef is that when the reef is formed in a circular fashion, and then you get a lagoon which is forming in the middle of the reef, which we normally refer to as atoll. This kind of reef, that is the circular reef and the atoll. And some of the reefs which are forming at the shell page, which cause as a barrier to the wave energy, that we call the barrier reef. So, in terms of geomorphic position, the reefs can be classified into fringing reef, then circular reef and the barrier reef. We also classify the reef depending on their geometry. If the reef body it is a completely lensoidal, then we call it a bioharm. So, what is a bioharm? Bioharm is a thick reef body which has lensoidal in geometry. Whereas, if it is bed parallel, then we call it a biostrom. So, bioharm and biostrom is the classification of the reef, which is basically depending on its geometry. There is another, in terms of genesis, the reefs are also classified, that is what is called the stratigraphic reef and the ecological reef. In the stratigraphic reef, it is a vertical aggradation and a large number of a stock of organic build up in the vertically, where the peripheral slope it is cut by the number of time planes. Whereas, in a ecological, it is a single unit body which is growing up associated with the water level, and it is the peripheral slope, it will be the one single time plane. So, all these are the different kinds of classification scheme of the reef that we basically talk about. Now, what will be the situation at the back of the reef? Commonly, this back of the reef, it is low in its wave energy, because most ocean wave that is baffled by this reef. So, what process will be dominating here? Commonly, tidal process dominate here. If the tidal process dominate here, then I will get the tidal flat on the rear part of the lagoon that is will be formed. but if for some reason the wave energy dominate, then we can also have the wave dominated the foreshore beach setting that is in the coastline of this lagoon. So depending on that whether tide or wave that is dominating, we can have a tide dominated or a wave dominated setting in the coastline of this lagoon. Now sometimes if this entire lagoon it remains within the photic zone, then some kind of patch reefs can be also generated within this lagoon, but they never grow up to the water level and make a wave baffling structure, but this remains in the form of patch reef. Now rim shelves they are generally tide dominated, whereas ramps they are generally wave dominated. Tidal fat forms on landward side of the rim shelf, whereas beach form on the landward side of ram shelf. Now energy level that decreases landward in a rim shelf, the energy level increases landward in the ram shelf. Biopopulation is restricted in a rim shelf, whereas biopopulation has much larger diversity in case of a ramp. Now lamination is always retained in a rim shelf because you get a low energy environment at the back of the reef, whereas laminations often is erased out in case of a ramp. Now sedimentation rate is always normally very high in a rim shelf because you generate a reef which is basically aggrading to the water level and baffle the wave, whereas sedimentation rate is low in case of a ramp. Deposition substrate is irregular in a rim shelf, whereas deposition substrate is relatively flat in a ramp, and lateral facies disposition is irregular and facies transition rapid and sharp in case of a rim shelf, whereas the facies contacts are gradational and facies belts parallel to the shoreline in case of a ramp. Now rim shelf again can be rimmed shelf again is classified into three different types. Number 1, accretionary rim shelf, accretionary. Number 2, bypass, and number 3, erosional rim shelf. In accretionary rim shelf, what happens that the productivity is very high and the relative sea level is steady, and because the productivity is high, that the shallow shelf part that will prograde on the force slope and the distal slope part. So there is a progradation because of the higher production in the shallow level, but there will be very less amount of vertical stacking. So that is the typical character of the accretionary margin. You can see this figure, there you get the supply of the sediment from the slope onto the slope part from this platform and this shallow platform that will migrate to the deeper part, and all these sediments that is because of the overproduction on it and the relative sea level is steady. So this overproducted sediment that will be supplied to the slope and the entire slope will be migrating on the distal part. Now we come on to the bypass. What happens that in the bypass there is a vertical stacking rather than a lateral migration. So what we get that as there is a vertical stacking and vertical aggradation, there will be very little amount of sediment that will be available on the slope, and it will not supply much sediment in the slope. So the fundamental difference between a accretionary and the bypass is that in the accretionary it is a lateral migration because of the higher productivity. In case of bypass it is a vertical stacking rather than lateral migration, and there the sea level relative rise of sea level that is reasonably fast. Now this is a bypass margin where you can see that there is very less amount of sediment that is supplied onto the slope. Whatever little amount is supplied, that is totally bypassed and it is deposited at the base of the slope, and mostly the growth it is a vertical growth rather than the lateral growth. So this portion which is very wide there, shelf portion, that is very narrow here, and it is not just this narrowness is just because it is not prograding but it is vertically aggrading. Now in case of erosional, it is the lower sea level where the margin is dissected by different kind of energy such as tidal and wave, and the total margin is dissected because the margin is exposed and the relative sea level is falling. Now coming on to this, it is a erosional margin. You can see that the sea level is has dropped, the sea level has dropped, and because this carbonate platform that is now exposed to different kind of erosional agency. So, it is getting eroded and the eroded material that is at the base of the slope, it is getting deposited. So, in both the earlier cases, the water level is high, but the carbonate productivity variation that is causing the variation in the geometry. Here the water level is low, and because of the erosion of the platform, the sediment is supplied to the base of the slope. So, both this accretionary and bypass, these are two kind of behavior of the rim shelf when the sea level is relatively stationary or it is rising fast. Whereas, the erosional is that when the sea level is falling and then the platform, it is exposed to different kind of energy. So, depending on the what kind of sea level it is exposed to, the rim shelf that can have these different kinds of geometry. So, we have reasonably discussed about the ramp and the rim shelf. Now, let us have some idea about the epiric platform. Now, what is a epiric platform? It is a very low gradient cratonic surface which is round, and that basically is essentially it represents from the subtidal to intertidal zone, subtidal to intertidal. The energy level is always very low and the tidal energy is further low. So, that kind of condition where a large cratonic platform, it is drowned and it is representing a subtidal to intertidal kind of situation, then we call it a epiric platform, which is a little subjective in the interpretation in the ancient succession. Now, we come on to the isolated platform. If you remember in my first figure, I had drawn a kind of figure where you have a isolated platform. That means the shallow water carbonate, that is the shallow water carbonate, it is surrounded by deep water carbonate on either side. Shallow water carbonate, it is surrounded by deep water carbonate, and commonly what happens that there is a formation of the lagoon in the middle part of it. This is a typical kind of situation where you can have the reefs that is being formed and which is taking at par with the sea level. So, the margins of this that goes on growing with at par with the sea level, but there is a less amount of growth in the middle part, and that basically is caused the kind of lagoonal system which we normally refer to as the atoll. Now, coming on to the drowned platform. This happens when the sea level is very high and the entire carbonate platform is flooded and the relative bathymetry on the platform that goes below the photic zone. So, the entire carbonate productivity gets stopped. That kind of platform where the shallow water carbonate, it is being buried under the deep water phases where the carbonate production is stopped, that we normally refer to as the drowned carbonate platform. Now, what are the common kind of transition that we notice in our rock record? A rimmed shelf may change to ramp due to the reef growth. A shelf can develop within a ramp setting due to subsidence. An epiric platform may evolve into ramp, shelves or basins due to tectonic activity, or any of the above discussed. The carbonate platform may become drowned or incipiently drowned platform due to rapid rise in sea level. Now, we will discuss the response of carbonate platform in the change in the sea level, that how carbonate platform they respond to the different kind of sea level changes. Now, it all is a function of the relative sea level change and the productivity within the carbonate platform. That if the carbonate productivity can keep at par with the sea level change, then the carbonate platform aggrade. If the carbonate platform cannot keep pace with the change in the relative sea level, then it gets drowned. So, all these things that play a major role, that what is the productivity of the carbonate platform. And then now, just if we think of a suppose we think of a rimmed platform. Now, what is it? How is the rimmed platform? As we have already drawn that this is what is a rimmed platform. You have the sea level, and this is where the your reef system is there. There is a lagoon. So, suppose sea level is rising, then what will happen? That if this platform geometry wants to remain same, then if the rise in the sea level is there, this reef system also has to grow to keep pace with the rise in the sea level. But if this reef this production is high and there it is not, the production is high, then this will become more and more the deep water and the more low energy. But if the productivity also becomes high in this zone, then this whole thing gets aggregated and the whole thing becomes a platform, the flat platform, that is what is called the ramp type. So with rise in sea level, with excessive sedimentation, there is a rimmed shape that can change to the ramp type just because the high productivity of the system. So all these, what we discuss, that how the productivity and the relative sea level change, that will cause the different kind of change in the carbonate platform. Now we will now come into the detail of the different kind of changes. Suppose that we have a narrow platform, then if I have a high tectonics but the low sedimentation, then normally the width of the carbonate platform will be low. But if the tectonic control is low but productivity is high, then we can have a wide platform that will be resulted as a result. Commonly, the stages of the carbonate platform in terms of the sea level change, they are classified into certain stages. Number 1 is drowning of platform. When the rate of rise of sea level is very high and the carbonate platform cannot cope up with its productivity with the rise of sea level, and the entire carbonate platform that gets submerged, that we call the drowning unconformity. This is one stage. Then we talk about the catch-up phase of carbonate platform. What is this catch-up phase of carbonate platform? That when the relative sea level is rising, so if I see the relative sea level curve, a relative sea level curve can be something like this, that the sea level from the low level it will be rising. But when it will start is rising, the slope of the relative sea level, that will be very low, and then it will pick up and the slope becomes very high. And commonly if we find that the entire geometry of the relative sea level curve, that will become a sigmoidal kind of shape. A carbonate platform will start with the initial slow rate of rise, what we call the startup phase of the carbonate platform, and as the relative sea level will be rising at a steeper slope, it will try to catch up, because it will always try to remain within the photic zone of the ocean. So because it wants to be always in the photic zone to have its productivity, it will try to catch up. So what we say, this is the phase what we call the startup. Then this is the portion what we call the catch-up phase, where the carbonate platform will always try to catch up to the rise of the sea level. And once the sea level comes to this zone, when it is stabilized, then it is the only duty of the carbonate platform is to keep it with the sea level, and then that what phase we call the keep up phase of the carbonate platform, that it remains at par with the sea level and continues its productivity. That is the kind of situation that it happens. Now the other kind of situation what I can expect, what I have already discussed, the drowning, because the relative sea level is rising very fast, carbonate platform cannot keep up with that, it get drowned. Now if the carbonate platform can keep up with it, then this is the story of the startup, catch up and keep up. And if the relative sea level is falling, then we get the formation of the unconformity, because the carbonate platform will be exposed and that will form an unconformity in it. So in this module what we have discussed, that will help you in understanding the role of carbonate platform as a hydrocarbon reservoir as well, because all this knowledge of the phases disposition, the porosity, permeability, the role of tectonics, role of sea level, and how carbonate platform they respond to these different kind of controls, that will help you not as a sedimentarist but also as a hydrocarbon explorationist, whereas the a large amount of the world hydrocarbon reserve that we get in the carbonate reservoir. I hope you have enjoyed this module on carbonate platform, and the other reading materials is already available in your e-module, so that you can consult for your further knowledge on this aspect. Thank you.